Assalamualaikum. Assalamualaikum. How are you, Shavi? I'm not getting your voice. Hello. Are you getting my voice? I'm not getting yours. You can leave a comment. You can rejoin. Just leave the meeting and rejoin the meeting. Assalamualaikum. Assalamualaikum.
Hello.
Yes, now clear. Is my voice is clear now?
Yeah.
Okay, so I hope you are doing well and everything is going well over there.
Yep.
Yes, so are you ready for today's lecture?
Yeah.
Okay, so today is our fourth lecture. Have you prepared our previous lecture, what we did in our last lecture about motion graphs?
Yeah. I've done the homework and I've sent it to my mother, so she'll send it to you
Oh,
today.
okay, sure. You can share by today with me, so I will check that.
Yeah.
Okay, so let's start our today's lecture. Let me share screen with you. My screen is sharing.
Yeah.
Okay, so today is our lecture number 4, and in this lecture, basically we will discuss about equations of motions, okay, which are very important to understand. Overall, there are three types of motion which we have to understood. So this all lecture is about those three equations of motions. So in learning objective, basically we will have to understand the uniformly accelerated motions. What are uniformly accelerated motions? You already know what is acceleration.
hmm
And if a body is moving with constant velocity, then the acceleration is said to be constant. So in equations of motions, The main factor is that your acceleration must be constant, not variable. I
Mm.
hope you know what is meant by variable and constant.
Yeah.
Yes, variable means acceleration is continuously changing, but constant means over the whole period of time, your accelerations or velocity value remains same. So in this scenario, equations of motion, your acceleration must be constant. And
Mm.
basically, second part, we will learn those three equations of motion. What are those? And when we discuss, then we apply those equations of motions to solve some practical problems. And we will also link those three equations of motions with our motion graphs, which we did in our previous lecture. Like, okay.
All right.
Okay, so here there are some conditions which I already mentioned you that in equations of motions, your acceleration must be constant. If your acceleration is not constant, you cannot apply equations of motions to that problem. Or you can only apply those equations whenever your acceleration remains constant. And the second condition is you have to relate displacement, initial velocity, final velocity, acceleration, and time. These all factors we have to use in our equations of motions. You will see whenever we will start. Okay, so let's start. What are those three equations of motions? Basically, these are the three equations of motions. Basically, these equations relates five key physical quantities. You already know what is initial velocity, which is the velocity which your body just starts, and the final velocity whenever your body stops. And your body must have some acceleration which is constant, and they must acquire some time, and also the displacement covered by the body. So these all factors we have to use in our equations of motions. All right.
Mhm.
Perfect. Okay, so we have to use this under the condition of uniform or constant acceleration. So let's discuss the first equation of motion. This is our first equation of motion. How you can read this as V equals to U plus AT, whereas this V stands for the final velocity and this U stands for the initial velocity. A, you know that is basically the acceleration, and T is basically the
Time.
yes time. So whenever you have to calculate the final velocity as well as initial velocity of some body, if that body is moving with a constant velocity and taken some time, you must have to use this equation of motion to solve that problem. Okay, this basic equation gives you the final velocity, which is represented by this v. Okay, v represents the final velocity. All right, and
Mm-hmm.
this u represents the
Initial velocity.
yes, initial velocity. And here is the acceleration, and time is the time that the body takes. So these all factors given, initial velocity, acceleration, and time is given, and they ask you to find the final velocity. So you can use this equation to solve that. We will also see the problems. Else you will only understood this is your first equation of motion. V equals to u plus at. Keep remember this, okay?
Mm-hmm.
And if they ask you to find the initial velocity, what you will do?
The U plus or U minus V or V minus U.
Yes, if they ask you to find the initial velocity, you know this u is basically the initial velocity, then you can move this at to the other side. So now your formula becomes u equals to v minus at. I think you know that whenever you move something to the other side of the equal sign, the sign changes.
Mm.
Do you know this
Yeah.
concept of maths?
Yeah.
So yes, so if they ask you to find the value of u, what you have to do is to just move this at to the other side and make a minus sign. So then it becomes u equals to v minus at. And if they ask you to find the final velocity, you can use the same relation. Okay,
Mm-hmm.
so this is our first equation of motion. And let's move on towards our second equation of motion. Basically, second equation of motion is helpful to find the displacement of a body. Okay, you know what is displacement? The shortest distance covered by a body is called as the displacement. Okay,
Mm-hmm.
displacement and distance are the same factors, but the only thing that differs between distance and displacement is that distance is the whole period, okay, but displacement is basically the shortest path that your body travels. So second equation of motion is helpful to find the distance or displacement of a body. You can see here is S. This S basically stands the displacement of an object, and here the displacement is equals to ut, whereas u is the,
Initial time.
yes, initial velocity.
No.
U is the initial velocity, and it's the product with time plus 1 by 2 at square. A represents again acceleration and t is the time square. So whenever question asks you to find the distance or displacement of an object, and all other factors must be given, like the body's initial velocities must be given, the time taken by the body is also given in the problem, and acceleration of the body is also given, and they ask you to find the how much distance your body covers. So you can use this formula, this equation of motion, to solve that problem. All right.
Mm-hmm.
Okay, so this is the first equation of motion, this is the second equation of motion. Now let's move on towards the third equation of motion. Basically, third equation of motion is the combination of first and second. If our problems not solved by first equation of motion, if our problems not solved by second equation of motion, then we can use our third equation of motion. You can see in third equation of motion we have the final velocity, which is represented by v, as I mentioned you before, and u, which is the initial velocity, and a, which is the acceleration, and s, which is the,
Speed. Oh no,
uh,
displacement.
yes, displacement, or you can say the distance. Okay, so whenever question asks you to find the distance, you can, if this is not solved by your second equation, you can move on towards the third equation of motion, and you can easily find by this, because in this equation you can see we have all factors like final velocity, initial velocity, and the displacement.
Uh,
Okay,
mm-hmm.
this equation links the square of the final and the initial velocities with the acceleration and displacement. It is also useful when time is not known, okay, because you can see here, do you see any factor of time?
Um, no.
Yes, no. So in problems, sometimes time is not mentioned. So you cannot able to use your first and second equation of motion, because as you can see in first and second equation of motion, here is a time. Okay.
Mm-hmm.
But whenever the time is not given, you will directly move towards the third equation of motion, because we don't need any value of time and we can solve our relations. Okay,
Mm. Yeah.
so these are basically the our equations of motions. Have you understood?
Yeah.
Okay, keep remember those three equations of motion. We will use these equations in our problems next. Okay. So let's move next. These notations I already mentioned you. This u is basically the initial velocity, and you know what is the unit of velocity?
Meters per second.
Yes, meter per second. So if that is final velocity, the unit remains same because it's a velocity. And what's the unit of acceleration?
Meters per second squared.
Yes, meters per second square. And the unit of time is seconds. And what is the unit of distance or displacement?
Meters.
Yes, meters. Okay. Now let's move on towards the derivation for velocity time graph. Basically, this motion graph we already discussed in our previous lecture. In this, you can see the area under the curve. As I mentioned you before in previous lecture, that whenever you draw your velocity time graph, and the area under that curve, that represents the,
uh, distance.
yes, the distance covered by the body. So here again, this thing is mentioned that area under VT graph means velocity time graph gives you the displacement. And we know that displacement is basically in our second equation of motion. S is equals to Vt plus 1 by 2 At square. That's why we use this. S equals to Vt plus 1 by 2 At square. How this equation comes? This equation comes by using, you can see whenever we draw a graph of velocity time graph, you can see it makes which type of shape it makes.
Triangle.
Yes, a triangle. And you know what is the area of triangle? Do you know the formula of triangle, area of triangle?
Is it A equals pi r squared, or
Yes.
A
Uh,
equals,
yes,
I can't remember.
basically the area of triangle is basically 1 by 2 base into height. Half multiplies by base multiplies by height. So here is the height, okay, which
Mm-hmm.
is the velocity, and base, which is the time, okay,
Mm-hmm.
okay. So this is basically the velocity time graph, which area under the curves basically gives you the total distance covered by the body, and how you can calculate the actual value of that distance by using the equation of motion, by using the second equation of motion, which is this: S equals to Vt, S is equals to Ut plus 1 by 2 At square, where this U represents the initial or final.
Initial.
Yes, U represents the initial velocity. Uh, have you understood?
Yeah.
Okay, now let's move on towards our practical examples regarding those three equations of motions. So, you, okay, let's start. So, problem number one, it says a car starts at 5 meter per second. So,
Mm.
which thing, what is this? 5 meter per second.
Uh, velocity.
Yes, velocity. Which is velocity? Initial or final?
Initial.
Initial. How you know that?
Because it says final, find its final velocity. Well,
Yes, because he mentioned here what starts.
mm-hmm.
A car starts means this is the initial velocity, right?
Yeah.
A car starts at 5 meter per second means this is the initial velocity, and acceleration is the car moving with an acceleration of 3 meter per second square means this is the value of acceleration for 4 seconds. Time is also given, which is 4 seconds. What he asking you to find its final velocity, right?
Mm-hmm.
So if you remember, I told you whenever they ask you to find the final velocity, which equation of motion you have to use to solve the problem?
Uh, uh, U plus AT.
Yes, which is the first equation of motion, right?
Yeah.
Perfect. So you know what is the first equation of motion? V equals to u plus at, and v is the
Mm-hmm.
final velocity, which is the required, and u, which is mentioned here, 5. So u is 5 meter per second, which is here. Acceleration, which is 3 meter per second square, and time, which is 4 seconds. So
Mm-hmm.
here you have to put the values. V equals to u plus at. The value of u is 5. The plus a value is 3, which is the acceleration, and the value of time, which is 4. So 4 multiplied by 3 becomes 12, and 12 plus 5 equals to 17. So the
Mm-hmm.
final velocity of the body is
17 meters per second.
17 meters per second. So this is how you can find the final velocity of a body by using the first equation of motion.
Mhm.
Fine. Now move on towards our second example. What it says, a cyclist moves from rest with 2 meters per second. A cyclist moves from rest. What it means?
Uh, that there's moving from stopping
Yes, this is a cyclist moves from rest. Means their initial velocity must be,
zero.
yes, zero. That's why, because your cyclist moves from rest, and rest means their velocity is zero. That's why you can see the initial velocity is zero. With 2 meter per second square, what is this given?
Uh,
They say nothing about this value, but how do you know what value is this? By just seeing their unit.
uh, because it's got the squared, so it's acceleration.
Yes, because the unit is meter per second square. So from this, this value is basically the value for acceleration. All right,
Mhm.
wonderful. So the initial velocity is zero, and the value of acceleration is 2 for 6 seconds. So the time is also given, which is 6 seconds. What he asking you to find the value of displacement means how much your body covers the distance. So if you remember, I mentioned you whenever they ask you to find the displacement or distance, which equation of motion you're supposed to use. If time is also given,
Uh, S equals ut plus half at squared.
yes, you have to use the second equation of motion, which is this s equals to ut plus 1 by 2 at square. Whereas u represents the initial velocity, the value is 0, so we put 0 here, and time, which is 6. So 6 multiplies by 0 becomes,
Zero.
yes, that's why 0 is here. Okay,
Mhm.
sounds good. Okay, 1 by 2, at square. The value of acceleration is 2, and the value of time is 6. 6 square. So 6 square becomes 36. 36 multiplies by 2 divided by 2. You will get your answer, which is
36 meters.
46 meters. So this is the total distance that your cyclist has covered. Perfect.
Hmm.
Okay, so this is how you can find the distance covered if the acceleration as well as the time is given. Now, let's move on towards the third example. A motorbike starts at 10 meters per second. So, which value is this?
Uh, velocity.
Yes, velocity. Which velocity?
Um, initial.
Yes, initial, because here you can see the word starts.
Hmm.
Okay, a motorbike starts at 10 meters per second, means the initial velocity's value is 10 meters per second. And now the acceleration is also given, which is 4 meter per second square. So A equals to 4 meter per second square. Our a distance of 45 meters. Now the value of distance is given. Okay. This is the value of S, which is 45. Okay. What he asking you to find the value of which velocity?
The final velocity.
Yes, final velocity. Do you see any time is mentioned in the problem?
Uh, no.
No. So if you remember, I told you whenever time is not given, which equation of motion you have to use?
The third one.
Yes, the third one, which is v square equals to u square plus 2as. Okay.
Hmm.
So here the value of u, which initial velocity is 10 meter per second, the value of a, which is 4 meter per second square, and the value of distance, which is 45 meters. And asking you to find the final velocity. And we know this is the final velocity, v square. So we just have to put the values here. U value, which is 10, so 10 square plus 2 value of acceleration, which is 4, and the value of distance, which is 45. You just have to calculate 10 square 100. 4 multiplies by 2 multiplies by 45, you will get 360. 360 plus 100, you will get 460, right? But
Mm-hmm.
here you can see it's v square. But we need only the value of v, because v is the final velocity, v square not. So how you can remove the square, do you know?
The square root it.
Yes, if you remove the square, you just have to take square root on both sides. So just take square root here, and you have to take square roots on the other side here also. So this square cancels with this square root. You will only get v, and square root of 460. The answer is
21.45 meters per
yes,
second.
21.45 meter per second, because it's the final velocity. Any question?
No.
Okay. Here is our fourth problem. It says a car increasing speed from 8 meter per second to 20 meter per second. So which values is this is given?
Velocity.
Yes.
Oh, acceleration.
Oh, yes. So 8 meter per second is initial or final?
Initial.
Yes. Speed from this to this. And 20 meter per second is?
Final.
Yes, final. So initial is 8, u is equals to 8 meter per second, and v equals to 20 meter per second. And the value of acceleration is also given, which is 3 meter per second square. What he asking you to find the
Distance.
level. Again, there is no time mentioned, so we have to use the third equation of motion, but we have to rearrange our third equation of motion, right? Because we have to find distance. So
Mm-hmm.
how we can rearrange our third equation of motion?
Uh,
You can see this is our third equation of motion. This is our
mm-hmm.
third equation of motion. And whenever we have to find this value of s, okay? So what we have to do, we have to move this u square to the other side, right?
Mm-hmm.
So it becomes v square minus u square when u square goes to the other side, right?
Mm-hmm.
And on the other side, it's 2as. But we have to find the value of only s, not 2as. 2a is extra on this side. What we have to do, we have to divide 2a to the other side. Alright?
Mm-hmm.
So it becomes v square minus u square divided by 2a equals to s. Right?
Mm-hmm.
So you can see here, I wrote here, you can see s equals to v square minus u square divided by 2a. You just have to rearrange your equation for s.
Mm-hmm.
Else remains same. You just have to put the value of final velocity, which is, you can see 20. So 20 square minus initial velocity square, which is 8 square, divided by 2a. 2, and the value of a is 3. So here is 2 multiplies by 3. By taking the square of 20 minus 8 square divided by 6, you will get your answer, which is 56 meters.
Mm-hmm.
Do you understood how you can rearrange the equation? Any question related to this?
No.
Okay. I hope your math is good.
Yeah.
Okay. Are you taking classes of maths too?
Mm-hmm.
Okay.
Well, I'm only doing that in school.
In your school?
Yeah, I'm only doing math in school.
Okay, maths in school. Sure. So let's move on towards next equation. Next problem. A ball is thrown upward and reaches a velocity 0 meter per second. So this is which velocity?
Or final.
Final velocity, because a ball is thrown by somebody. but your ball reaches a maximum point and stops there. So this basically 0 meter per second is the final velocity. Okay, so 0 meter per second is your final velocity. And what is the acceleration of your ball, which is minus 10 meter per second square. And also time is given, which is 2 seconds. They're asking you to find the displacement. And you know that whenever time is given and you have to find the displacement, which type of equation you have to use?
Uh, the second one.
Yes, second equation of motion, which is h equals to ut plus 1 vt plus 1 by 2 at square. Okay.
Yeah.
Okay, so here S is equals to UT. So U is basically initial or final?
Uh, initial.
Yes, U is initial. But you can see here a ball is thrown upward and reaches a velocity of 0. And here you can see your acceleration is negative or positive.
Negative.
Yes, so if acceleration is negative, you can take your final velocity as initial velocity. Keep remember this important note, okay?
Mm-hmm.
Whenever your acceleration is negative, you have to take your final velocity as initial velocity. As I told you, this is our final velocity. So in this scenario, you have to take this velocity as your initial velocity. Why? Because your acceleration is negative here.
Mm.
Okay. So now by just putting the value 0 multiplied by 2, it becomes 2 minus 1 by 2 at squared. The value of a, which is minus 10, and the value of t, which is 2. So after solving, you will get your answer, which is
20 meters.
20 meters. Any question?
No.
Okay. So this is our final example. A runner starts at 3 meter per second. So this is there.
Sorry.
A runner
Oh,
starts at 3 meter per second. So 3 meter per second is there.
initial
Initial
velocity.
velocity reaches 15 meter per second. This 15 meter per second is there.
Final velocity.
Final velocity. And what's the acceleration of the body?
Um, 4 meters per second
Per
squared.
meter per second. What they're asking you to find?
The time
Yes, the
taken.
time. Again, the time is given, and the initial and the final velocity is given. And we know that whenever initial and final velocities are given and time is given, we must have to use our first equation of motion, because in our first equation of motion, there is final velocity, initial velocity, acceleration, as well as time. But again, you have to rearrange your equation for time. You have to do the same procedure. You have to move this u to the other side, so it becomes v minus u. Am I right?
Mm-hmm.
And here we have to solve for t. A is extra, and you have to divide this a to the other side. So your equation becomes u v minus u divided by a. So this is how you rearrange your equation for time.
Mm-hmm.
So now you just have to put the values. You know what is the value of final velocity is 15, initial velocity is 13, and the value of acceleration is 4. By just solving, you will get your time, which is
3 seconds.
3 seconds. So any question regarding these problems?
No.
Okay, so this is how you can solve your problems. Where you can easily find your final velocity, initial velocity, you can find acceleration, you can find time, you can also find the distance covered by the body. So all those factors can be found by those three equations of motion. So you must have to remember those equations of motion.
Mm.
So here is some quick quiz for you. So you can tell me which formula gives the final velocity?
V equals UAT.
Yes, this is first or second or third?
First.
Yes, first. And can you tell me what is the unit of acceleration?
Meters per second squared.
Yes, good. Can you tell me if a ball is dropped from rest with an acceleration of 10 meter per second square for 3 seconds, can you find their final velocity?
Uh,
First, tell me which equation of motion you will use in this scenario.
the first one.
Yes, the first one, because
Uh,
initial
you
velocity is
can
given.
Yeah.
which is rest. Rest means initial velocity must be
0.
0 and find okay, and acceleration is also given and time is also given. So you can
Yeah.
easily find your final velocity, right?
Mm-hmm.
Okay.
30 meters per second.
Yes, which is 30 meter per second. So can you tell me if a car accelerates from 5 meter per second to 25 meter per second in 5 seconds? Find its acceleration. Can you find?
Uh, yeah.
In this scenario, which equation of motion you have to use?
The second one.
The first one.
Oh, the first
Because
one in
how you
structure.
can, how you see? Because you can see this 5 meter per second is basically the initial velocity. A car accelerates from. So it means this is initial velocity and this is the final velocity and this is the time. And we know that initial velocity as well as final velocity as well as time is mentioned in the first equation of motion. We do not use the second one because in second equation of motion we requires the value of distance or displacement. But in this problem there is no distance or displacement. That's why we have to use our first equation of motion and we again have to arrange our equation for acceleration.
Mm-hmm.
Okay, again, this is our first equation of motion. Again, if you want to find the acceleration, first you have to move this u to the other side. It becomes v minus u. And
Yeah.
if they are asking you to find acceleration, then extra. Then you have to divide t to the other side. So here your formula becomes v minus u divided by t. By just putting the values, you will get your answer, right?
Mm-hmm.
So this is how you can use those three equations of motions, and by just rearranging mathematically, you can easily solve. Can you tell me find the distance a motorbike covers in 4 seconds if it starts at 6 meter per second and accelerates at 2 meter per second square? Can you tell me which equation of motion we have to use in this scenario?
Um, the third one. Oh no, second.
Yes, second. Why not third?
Because it mentions time.
Yes, because they mentions time. In third equation of motion, there is no time. So that's why we can't use third equation of motion. And we
Yeah.
also not use first equation of motion because in first equation of motion we need uh, okay, we don't have distance, but here distance is given. Okay, we have to
Mm-hmm.
find distance, so we have to use our second equation of motion. So
Yeah.
time is given, which is 4, s is equal to ut. Initial velocity is also given, which is 6 meter per second, and the value of acceleration is also given, which is 2, and the value of time, which is also given 4. Just putting the values, you will get your answer, which is
40 meters.
40 meters, right? Any question?
No.
Okay. So this is your homework. There's three problems you can solve and send it to me
Mm-hmm.
next lecture. Okay.
All right.
In first problem you have to find acceleration, and in second you have to find how high means you have to find distance, and in third problem you have to find write a suitable formula to find the distance. In both you have to find distance, and in this you have to find acceleration. Any question?
No.
Okay. Not, we will close our today's lecture. Just wrap up this section.
All right. All right.
This PDF is attached. You can download. I will also send it to you.
All right. Okay.
Take care. Allah Hafiz.
I love fish.
You can send your homework. Okay.
All right. Okay.
Thank you.
Great. Thanks. Bye.
Allah Hafiz.
Office.